Okay, so question 15 just asks, what is the molar mass of KHP? So KHP isn't like just potassium, hydrogen, and phosphorus put together in a compound. It's actually a short form for a compound called potassium hydrogen phthalate. So it has a chemical formula of C8H5KO4. Okay, so to find the molar mass of KHP, it's going to be 8 times the molar mass of carbon, which you would just find on your periodic table, 5 times the molar mass of hydrogen, since there are 8 carbon atoms and 5 hydrogen atoms in KHP, plus the molar mass of potassium, so we don't need to multiply it by anything since there's only 1 atom of potassium. Lastly, plus 4 times the molar mass of oxygen. So now I'm just going to sub in all of their molar mass values. So carbon has a molar mass of 12.01 grams per mole. Hydrogen has a molar mass of 1.01 grams per mole. Potassium has a molar mass of 39.098 grams per mole. And lastly, oxygen has a molar mass of 15.99 grams per mole. Okay, so if we were to add up all these values, you get a final molar mass of 204.24 grams per mole for KHP. Okay, so let's see what the junior tutor said. KHP is potassium hydrogen phthalate. Its chemical formula C8H5KO4. Molar mass of KHP is equal to 8 times the molar mass of carbon plus 5 times the molar mass of hydrogen plus 1 times the molar mass of potassium plus 4 times the molar mass of oxygen. And they also got 204.236 grams per mole is the molar mass of KHP. Yep, so this solution is correct. Okay, so I think we have time for one more question. Question 16 asks, what is the formula for iron 3 oxide? So when you have a chemical name that has like a Roman numerals in brackets, that shows us that the iron has an oxidation state of +3. So if I were to write these as their ions, it would be Fe 3+, and oxide is just an oxygen anion, and it has a charge of 2-. So we would need 2 atoms of iron and 3 atoms of oxygen. So some people just like to, like, I'll show it as if it was just generally speaking, if I had an element that had a charge of plus X and another ion that had a charge of minus Y, if these compounds were to come together, the subscript of the first ion would have the same value as the charge of the second ion, and then the second ion, its subscript would have the same value as the charge of the first ion, if that makes sense. So finally, the formula for iron 3 oxide is Fe2O3. Okay, so let's see what the junior tutor said. The iron on the compound given has a charge of 3+ as stated by the Roman numeral number, while the oxide came from the oxygen with a charge of 2- as can be retrieved from the periodic table of elements. Following the rules on constructing the formula of compounds, the charge of the cation will become the subscript of the anion, while the charge of the anion will become the subscript of the cation. We now have a formula for iron 3 oxide as Fe2O3. Yep, so this solution is correct. Okay, so that is all the time we have for today's session. If you like today's Q&A and you'd like to be notified of when we do this next, please hit the notification bell and the subscribe button below. If you'd like to submit a question of your own, then check out the links in the description. Also, if you like today's video, go ahead and give it a thumbs up and comment, and don't forget to share with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.